Okay, we're starting this activity with the answers to goodness, where was it? Oh, I did that one already. We figured that we showed that was 13. We figured out that was 13. We did that. Oh yeah. Plot the points, explain how you would find it. They did explain. Notice right here they say the distance between points J and K is 10. So that's what that's what you should have gotten. And then this one right here, they just said find the distance. They didn't ask you to explain. Is 25 units. Okay, so you should have gotten 10 for this one, 25 for this one. The hypotenuse for this right triangle is 10. The hypotenuse for this right triangle is 25. Now, if you don't know how they did that, then that's what you need to attend one of the live question and answer sessions. You would just say, hey, I don't know how we did number 10 on activity 5-1. And because that's what we're doing right now, lesson 5-1. You don't know how they did number 10. And so you go in with that information, and whichever teacher is in that question and answer session will help you work it. Okay, now this one is where we're actually going to come up with a formula. And a lot of times students shy away from that, but it's really not that bad. Okay, why am I getting a notification? It's not that bad. We're going to try using this pen. Okay, so they've already see here's the hypotenuse, there's the 2 points, there's the coordinates. The only problem is we don't have numbers. But we know if we were finding this distance right here, and we know that this point, this coordinate for that point right there is going to be the same as the x value for this one, because if you'd start right here to get to this point, you would go over that far. Well, how far over did we go? Well, we went over that far. That's x2. And if we needed the coordinate, the y coordinate for that point right there, we would start right here and we would go over x2, and then we would go up just to this point right here, go over to x2, and then we would go up to that point right there and we would stop. Well, how high up is that? Well, that's up the same distance that this is up. So this y coordinate right here is y1, so this distance right here is also going to be y1. So this coordinate right here has values of x2 and y1. So if we want to figure out how far apart these two are, what kind of line are we on? We're on a horizontal line. And when we are just on a single line, what does the ruler postulate say we do? It says we subtract the two values. Well, what are the two values that we're subtracting? Well, we're subtracting this one right here, because it's the one on the right. We're saying x2 minus x1. So that's how far apart this one is. So the length of that line segment, and my triangle's kind of small, so I'm just going to blow it up over here. The length of this piece right here is going to be whatever answer we get when we subtract those two values, x2 minus x1. Okay, and what's the length of this one? Well, it's just a vertical number line, and on a vertical number line, the things that change are your y values. So how far apart are those two y values? The ruler postulate says that in order to find out how far apart two values are, my dogs. In order to find out how far apart two values are, you subtract the smaller one from the bigger one. So we're going to subtract the one on the bottom from the one on the top. So this distance right here is going to be whatever value we get when we say y2 minus y1. Okay, so we've just found the lengths of the legs of the triangle, of the right triangle. Okay. Now, the Pythagorean theorem says that if we want to find this, we take the leg, and we square it, the length of the leg. My pen's being slow. And we square it, and then we add that to the length of the other leg squared. And when we add those two distances together, that's supposed to equal this length right here, which is what we usually call C, and we square it. Okay, now we know what we can actually, since we don't have any numbers, we can't square this and add it together. But if we did, we would, that's exactly what we'd do. We'd subtract these, add it together, and square it. Subtract these, square it, and then we'd add those together. But just like we did on the other problem a while ago, let me see, what was that? We ended up with, I think on the problem that we worked before, we had 144 after we squared it plus 25. And that was equal to C squared. And then we said 169 was equal to C squared. Remember that stuff that we did? Well, what did we do next? Well, we don't want to know what is the value of the distance squared. We want to know what the actual length of the hypotenuse is. So how did we undo that square? We took the square root. Okay, so right here, and that gave us 13, right? So right here, the next step we're going to have to do is we're going to have to take the square root of whatever this value is in order to get that C by itself. We have to take the square root of both sides. We have to take the square root of this side, and we have to take the square root of this side. So it's ugly because it's a bunch of numbers and letters, and it's a little bit intimidating, but really, doesn't this just say find how far apart the x values are? And then this one says find out how far apart the y values are. Okay, find out how far apart the x values are, find out how far apart the y values are, square those numbers, add them together, and then take the square root. Now, they don't call this C, they're going to call it D. And what do you think the D stands for? Distance between 2 points. Oh, this pen is really going slow. Distance, I think I like the other way better, y'all. Distance between 2 points. The distance between 2 points. Good grief. The length of time it took me to write that. I'm really liking the other way better. That's why I just don't like writing on the web. Okay, so what did we just discover? Here we go. I was hoping that they would have the distance formula written down somewhere for you. I know they do. I'll find it. It's on your formula sheet that you get to use for sure. But use the Pythagorean theorem to write an expression for the length of the hypotenuse of the right triangle. So this is the answer that goes right here. Write a formula that can, oh no, this is also. I think the difference here, this is where we said C equals the square root. Oh, heaven's sakes. And this one is where we said, let's just call it D equals the square root and what's all underneath there. Okay. All right. I'm going to stop this because I'm pretty sure I've got a bug crawling down my shirt. So I got to take my shirt off.